We have a little piece of poor quality aluminium here, unknown kind. We have our little sketch. This is going to be a 90-degree bend for a cable. So this part here will sit in some sheet metal with a nut on the inside. And here we will have a plastic, I don't know what it's called, but it's a ferrule or something threaded that the cable goes through with rubber sealing. The problem we have is that this piece is only 65 millimeters thick, while this is round. Well, it should be 75. What I figured is that there is a 65 millimeter diameter piece hiding in here. That's 75 millimeters long. Just need to turn it the other way. So here's the strange setup. I've aligned it as best as I can. And I'll turn it down to 65 millimeters. And then turn it down or turn it around and turn the other end, and we'll see how it goes. Down the first side here. Didn't totally clean up there, but there is about 1 millimeter left on the diameter, or 40 thou. So to almost clean up there, and we'll see how it goes on the other side, if we can get it to clean up there too. So we have roughed it down, and the length is more than adequate. We needed 75 millimeters and we have got about 82 or something like that. It's the same on the other side here. Yeah, 81. Sorry for the camera again. There. And we have, this is the side where the hole needs to be, obviously. And on the diameter we have, let's see here, 66.2 about. So we have 1.2 to come off. I don't think that's enough to clean up this or this, but one of the sides won't matter because we'll have a big radius there. And on the other side we will have a cut down for threads. Let's look at the drawing. If we put it like that, for example, we have a radius there. So let's say that is about 5 millimeters. We have this here 10, so we're down to 60. That needs to be good. We have more than 60 in the middle here. Finish turned out pretty nice, especially for not trying. You can see the partial radius here, I guess. It's just a matter of skipping away with it, or using the radius gauge all the time to get it right. A little file work, a little polishing. The radius is done, and we have a little witness mark there, and we have this one, so we'll make the flat right here. The rest of the part is good. So now we'll turn it around and we'll machine the hole from the other side and try to make the threads. Or maybe we'll make the flat first. I decided to do everything on the lathe. I'm over here at the surface plate, and I marked center of the hole and the flat I'm going to make with a heat gauge, which I bought off eBay from some surplus. You can see where it's been before. Come a little way. The diameter is about 50 millimeters now. We need to go to 55, and this flat also needs to be 55 wide, and it's only 39 or something like that. So we need to go out 5 millimeters more in diameter, about so we touch the radius, and we need to go a little bit deeper so we get enough width here. Since we've got a good flat here now, we'll drill the hole about halfway through and we'll bore it to the suitable diameter. We'll start with 10 millimeter drill and then as big as we can go, less than thread diameter. changed to a bigger boring bar. I'm boring out to 38.4 or 5 millimeters, which will be the minor diameter for the thread. I've set everything up for threading now. I'm going to cut 16 threads per inch. I wish the machine had 17 because that's really close to 1.5 millimeters, but this is 1.58 I think. So we're there, CD1. 1 here on the tumbler, and C there, D there. We have the threading stop set there, so it kicks out before the threading tool hits the bottom of the hole. We finished the threads, and here's the cable thing. It screws in just fine. Threads are a little loose, but it's so strange since the pitch is off. And I had to cut a little bit more to get it to fit. I've turned this diameter to 59.8, which is the major diameter of the M60 thread. And this will be drilled away afterwards. Put a little chamfer there and a little chamfer here. So now we'll try to turn this outside thread, and we'll make the nut afterwards to fit this thread. I'll set the thread to kick out. We'll see how it works. I should have drilled the other hole deeper, because now I got a seriously interrupted cut in there. And I need to get to the other side of the other hole to get some clearance for the wires that goes through there. I bored it out as much as I can now. There's good clearance in there. So now I'll put a radius on here. That should be the final operation. We should get on to making the nut that should fit on here. I'm going to make the nut out of this piece of low carbon steel, or so it says. Who knows what it is? Doesn't really matter, there's no strength needed. It is 110 millimeters, and we need it to be about 80 millimeters outside over the corners of the hex, so I'll turn it down first, and then we'll mill the hex, and then we'll turn the threads inside and finish everything. That was a good cut. The depth of cut was 400 thousandths. So 5 millimeters depth of cut, 10 millimeters of the diameter. And the feed was 0.4 millimeters or 16 thousandths. We're going to plunge in 5 millimeters or 200 thousandths, so that when we mill the hex we don't have to mill end milling and side milling. So we'll just do 1 or 2 plunges and then we'll turn the inside so we get it concentric. The thread is just starting, so I think I'll take maybe 5 thou or something and we'll test it again. Threads are a little rough in there, but it's mild steel and I have to go slow because the max RPM when you're using the thread lead screw disengage is 200 RPM, so I'm going 183 RPM. I used thread cutting oil on the last pass and finished improved a little bit. Fit is quite good. I mounted the workpiece on the wading head and we'll try to lift it up here. So we managed to lift it up here. It was just about. I didn't make it. Anyway, we have to tilt the head this way because the Bridgeport clone doesn't have enough room between the table and the spindle. So this is the way we're going to do it. We have enough space there. And we'll use the direct indexing plate down here. It has 24 and 36 and 30 holes, so we can use whatever circle we want. And have loosened this is the lock and this is the gear engagement, so this is disengaged. So now we can just spin it more or less freely. I have one flat left to go. It's about 71.7 across the flats now. I was planning on 70, but the radius here looks pretty nice. So maybe I'll leave it like that. I'll do the last one and we'll see. It's too difficult to crank the handles and film at the same time, so there won't be any filming of this. I took one final cut of about 0.3 millimeters, so now we are at 70.5 across the flats. I think it looks okay. copper parting insert didn't like that at all. So we changed insert. And we'll make the groove a little wider before we continue. There it is. New insert worked. I don't know why the first one broke, but I think there was a hard spot in here somewhere, maybe. Yeah, who knows. It was a little bit rough. Then it went nicely the last millimeter or so. Both pieces are finished now. There was a little burr on the there in the thread relief groove, the aluminium piece, and that was the reason the nut didn't properly engage. But after I cleaned up the aluminium thread a little bit, everything goes together nicely. I think it turned out okay. Only thing I would have done differently was to do this hole first. Get this with a cable ferrule or whatever it's called too. So the cables will come through there, and there will only be a plastic edge to rub against, which I suppose should be okay since that's the way it's made. And here it will be smooth, so it should work.